Welcome, students. Today we're going to put on our automotive engineer hats and take a really close look inside the beating heart of your car, the internal combustion engine.
Now, you might be wondering how exactly does a tiny little electrical spark manage to move a 2-ton vehicle down the highway? Well, today we're going to solve the ultimate engineering puzzle, figuring out how we turn basic chemical energy into massive physical motion. All right, here's our roadmap for this explainer. First, we'll look at the car's heart, then the 4 simple steps of combustion, followed by the maestro and muscles, and finally, the engine's life support systems. Let's dive right in. Starting off with Section 1, the car's heart. So, the absolute core of this whole operation is the cylinder and the piston. It's actually a lot like riding a bicycle. Just imagine the cylinder is the open space your leg moves up and down in, and the piston, that's your foot, pressing down hard on the pedal to create power. And just like your foot pushes the pedal to turn the bike's gears, in an engine, the piston pushes down on a connecting rod. That rod spins what we call the crankshaft. It's a brilliantly simple way to take straight, up and down linear motion and turn it into the continuous circular motion that actually drives your wheels.
Moving on to Section 2, let's look at this cycle, which breaks down into 4 simple steps.
Think of the engine as a living thing that breathes in 4 distinct strokes: intake, compression, power, and exhaust. Honestly, it's easier if you just remember it like this: inhale, squeeze, bang, and exhale. First up is the inhale. The piston drops down, literally sucking in a mixture of air and fuel. Next is the squeeze. The valves at the top snap completely shut, and the piston surges back up. This pressurizes that air-fuel mixture, compressing it into a tiny space, like a tightly coiled spring just waiting to pop. And then, bang! A tiny spark ignites that highly pressurized mixture, creating a sudden explosion that violently shoves the piston back down. That is your power stroke. Finally, we get the exhale. The piston rises one last time to push out all that burnt smoke, totally clearing the chamber so it's ready for the next breath. Okay, Section 3, maestro and muscles, the cams and the crank. Now, with all these explosions happening, coordination is absolutely crucial. Up at the top of the engine, we have the camshaft. Think of this as the maestro. It perfectly times exactly when those intake and exhaust valves open and close. Down below is the crankshaft. These are the muscles of the operation, spinning incredibly fast from the force of all those explosive impacts. So, how do the maestro and the muscles talk to each other? They sync up via a heavy-duty timing belt. Because they're physically locked together by this belt, the camshaft knows exactly where the pistons are at any given moment, which lets it open the valves at the exact right microsecond. You know, you might have seen the letters DOHC on the back of a car before. That stands for double overhead camshaft. A lot of modern engines use a design with 2 maestros up top instead of just 1. It helps them manage multiple valves simultaneously, which basically just lets the engine breathe a whole lot better. And what about RPM? We hear that all the time. It stands for revolutions per minute. To put that into perspective, if you're cruising at 3,000 RPM, your engine's muscles, that crankshaft, are completing 3,000 full circular rotations every 60 seconds. Literally 50 explosions a second. The speed is just mind-blowing. Moving on to our final segment, Section 4, engine life support systems. As you can imagine, with all that heat and metal-on-metal friction, the engine would quickly destroy itself without some help. So it relies on an entire network of vital background systems to keep it alive. First, the intake and fuel systems are what actually feed the beast. We've got filters cleaning the incoming air, while dedicated fuel pumps send highly purified fuel right into the injectors, spraying a beautifully precise mist into the chamber. Next is cooling. To survive that massive, intense heat we talked about, a water pump is constantly circulating cooling fluids straight through the hot metal block of the engine. A thermostat regulates things, sending the hot fluid out to the radiator, where it gets chilled by passing air before looping back. Then there's lubrication. An oil pump blasts slippery oil into practically every moving metal joint to stop friction dead in its tracks. And here's a really neat detail. There are special little piston rings that act just like squeegees on a window, making sure all that oil stays out of the actual combustion chamber where the fire is. We also can't forget the electrical and ignition systems. The engine control module, or ECM, is basically the computer brain of the whole operation. It dictates the exact timing of the sparks. All of this is powered by the alternator, which cleverly recycles the engine's mechanical motion back into usable electricity to charge the battery. And finally, we have the exhaust system to vent all that waste. After the gases leave the cylinders, they pass through a catalytic converter, which actually strips out toxic pollutants. After that, a muffler dampens the explosive noise before the exhaust finally exits through the tailpipe.
It truly is an engineering masterpiece, isn't it? We're talking about thousands of controlled explosions per minute, managed by this absolutely perfect choreography of metal, air, and fluid. So next time you turn your key and hear that engine roar to life, try to picture that incredible mechanical symphony happening right under your hood. It makes you wonder, how will the cars of tomorrow improve upon this century-old design? Thanks for joining me on this explainer, and I'll catch you next time.